Hey everybody, it's Peter from peterstestprep.com. Today we're going to learn everything we need to know for the ACT about ellipses and hyperbolas and a quick review of circles. There is a worksheet, a printout that is available to you. You should print this out and follow along with the video. The link to the printout, you can find it in the description underneath the video. And as we go along through the lesson, we will pause every once in a while to have you practice questions. Do those questions. Pause the video, do them, then start the video back up and we'll go over them and then go to the next mini lesson. This is the best way to learn this. You're going to hang on to this worksheet and study it in order to prepare for the exam. So if you guys are ready, let's begin. Have the worksheet in front of me here, the best place to begin. Our review is with number 1 on page 1. We're going to do a quick review of circles. You should know how to do this before you start trying to learn how to do ellipses, but we'll do a quick review here. I will zoom in for us. We have our first equation, x squared plus y squared equals 9. That's your basic circle graph. The x squared plus y squared tells you this is a circle. Over here by itself is r squared, the radius squared. So this is a circle whose center is at the origin 0, 0, and whose radius is 9. And so check that, whose radius is 3, r squared is 9, and that's what our circle would look like. Hopefully you're a better artist than I am. But the form of the circle equation is always r squared by itself on the right side. The only other thing then that we can do with a circle is to move it, translate it. So let's draw a circle whose center is at 4, -1, but with the same radius of 3. Whoops, that's going to go off our graph. That's all right. And the form of the equation will be x minus 4 squared plus y plus 1 squared equals 9. So by itself over here is still r squared. The center of the circle is 4, -1. You will notice that in the equation, the 4 and the -1 are distributed to the x and the y respectively. The x coordinate 4 goes with the x, the y coordinate -1 goes with the y. Those are the coordinates of the center, but it's opposite sign, opposite sign. Translations in parentheses are always opposite sign. Thus, the generic form of the equation of a circle is always written as x minus 8 squared plus y minus k squared equals r squared, where h, k is the center. And again, you guys should know this if you're doing this little section here. In order to learn how to graph an ellipse, I want you to pay very close attention here in number 2. We're going to graph a circle again. We're going to graph the same circle, x squared plus y squared equals 9, but I'm going to follow a particular process. First, I'm going to divide across by 9. So now I have x squared over 9 plus y squared over 9 equals 1. My center is at 0, 0. What I'm going to do is I'm going to take the number underneath the x squared, which is 9, and take the square root of that, and that is equal to 3. So I'm going to count 3 units along the x-axis or the horizontal axis from my center, 3 in each direction. 3 to the right and draw a point in, 3 to the left and draw in a point. The number underneath the y squared, the 9, I will also take the square root of that. That gives me a 3. So I'm going to count 3 units up and 3 units down from the center. And I basically have then my 4 points, which when I draw a circle around them, there's my same circle, our familiar circle here with the radius of 3 in the center at the origin. Now let's jump down to number 3, and we're going to do the same process that we just did to graph the circle, but we're going to have different numbers underneath the x squared and the y squared. So x squared over 4 plus y squared over 16 equals 1. Again, my center is at 0, 0. Now the number underneath the x squared is a 4. I take the square root of 4 and we get 2. So I count 2 units to the right and to the left of the center. The number underneath the y squared is a 16. I take the square root of that. That's 4. Now I'm going to count 4 units up and 4 units down from the center. And after I plot those points, and I'm going to connect all of those dots, and I have not a bad looking ellipse here. So that's how you graph an ellipse, and that's how you do the equation of an ellipse. A couple of probably unimportant bits of vocabulary here. We don't technically have diameters, I think, in an ellipse. We'll call them axes. The major axis is what you might think of as the long diameter, and in this case here it has a length of 8, and then the minor axis would be your shorter diameter, in this case 4. Let's go over now to page 2 on the top left, and I'm going to have you guys do 3B and 3C. So in the first one, you're going to graph an ellipse. In the second one, you're going to figure out the equation of the ellipse. Go ahead and stop the video, and when you're done, we'll return. Looking at 3B, our center is still at 0, 0. The number underneath the x squared is a 25, so we take the square root of that is 5. So I'm going to count 5 units to the right and 5 units to the left of the center and plot a point. The number underneath the y squared is a 9. We take the square root of 9, which is 3. So I count 3 units up and 3 units down. Plot those points. And when we connect them, and there's our ellipse there. In 3C, now we have to come up with the equation for the ellipse. So an important point here is, number one, it's always going to be 2 fractions added together, and they're always going to equal 1. That's your standard form of the ellipse that you use when you're trying to analyze and graph it. We have x squared on top in the first fraction, y squared in the second equation. Now, underneath the x squared, you count the number of units from the center to the left and to the right until you hit the ellipse's curve in either direction. It's 2 units to the right and 2 units to the left from the center, so 2 squared is 4. We just go in the opposite process. We have 6 units counting from the center upwards and downwards to reach the ellipse. 6 squared is 36, and there's our answer. Let's go to 3D, and what we're going to do is translate our ellipse. So it's the exact same process that we have been doing so far with the ellipse, except the center is going to be in a different location, and the rules for finding the center are exactly the same as finding the center in the equation for a circle. So looking at 3D, this should look familiar to you if you just look at the numerators, x plus 1 squared plus y minus 3 squared. That's telling us that the center is at -1, 3. Let's do the same process. Underneath the x plus 1 squared is a 25. Take the square root of 25 is 5. 1, 2, 3, 4, 5 units to the right. 1, 2, 3, 4, 5 units to the left. Underneath the underneath the y minus 3 squared is a 9. We take the square root of 9, and that's 3. So 3 units up, 3 units down. Plot those points. And there's our ellipse, and a little bit more attractive than what I've been doing. Let's have you give this a try now. You do 3E and 3F, pause the video, come on back when you're done. Looking at 3E, the first thing to do, step 1, is find the center, and the center is 4, 2. So 4, 2, like so. Underneath the x minus 4 squared is a 4. We take the square root of 4 and give us 2. And this process is becoming easy. Underneath the y minus 2 squared is a 16. Take the square root of the 16. That gives us 4. So we count 4 units up from the center, 4 units down from the center. And there's our graph. And that's my best one yet. In 3F, the first thing to do is to find the center. Well, you got to eyeball that. And it looks like it's at 2, -1. So let's do the numerator first. We're going to set it equal to 1. Let's set up our fractions like so. On top, And the left-hand fraction will be x minus 2 squared, opposite sign as before. And in the right-hand fraction, y plus 1 squared. Now we've got to count the number of spaces to the right and the left from the center. It's going to be 4, so I square that to 16. That goes underneath the x squared term. 3 units up and down from the center, square the 3, and a 9 goes underneath the y plus 1 term. And there's our equation for the ellipse. We'll go to page 3, the next page here. And on this page now, there's a set of 4 problems for you to do. So give these guys a try. Now, for some of them, there's no coordinate plane provided for you. That would be typical on the ACT. You'll have to make a sketch. So it doesn't have to be extremely detailed, but you've got to be able to keep track of all of your points. So if we say sketch here, just draw it in with enough detail to help you answer the question. All right, go ahead and try all 4 questions, 4A, 4B, 4C, 4D, and when you come back, we'll go over them. Go ahead and pause the video. Let's start off by looking at 4A. We're going to sketch this ellipse, and then when it says to label the coordinates of the highest, lowest, leftmost, and rightmost points on the ellipse. So I'm just going to do a sketch like this. Again, the first step is always find the center, -3, -1. It's opposite sign. So let's do that. -3, -1. Underneath the x plus 3 squared is a 9. Take the square root of 9. That's equal to 3. So that's going to be 0, -1 over there. Count another 3 units, this time to the left of the center. That's -6, -1. Underneath the y plus 1 squared is a 36. So we take the square root of that. That's 6. So we're going to have to count 6 units up from -3, -1. Well, 6 units up from that is -3, 5. Drawing another 6 hash mark going down. From -3, -1, 6 units down takes us down to -3, -7. And we can connect all of those dots there. And there's my lovely ellipse. And you can see that I've labeled the highest, lowest, leftmost, and rightmost points in the ellipse. Let's go to 4B. The point 3, y lies on the graph of the ellipse of the pictured below. If y is greater than 0, let's find the value of y to the nearest tenth. In a situation like this, when they give you a picture of an ellipse, the only reason they're going to be doing that is for you to find the equation of the ellipse. You have to find the equation. Now, luckily for us, the center's at 0, 0. So I know it's just going to be x squared on top plus a y squared on top equals 1, always equals 1. 5 units right and left. Well, this is getting pretty easy for you, I expect. There's the equation of the ellipse. Now, there's a point 3, y. Well, there's 2 points 3, y. You can see me drawing them in there. But y is positive, so that means that we're going to be looking for the y coordinate of that point there. All right, a really, really important point. When you have an equation and you have a point on the line, even if you don't know all of the coordinates like here, plug the coordinate point in to the equation if you don't know what else to do. But that's a typical setup. When given an equation and a point on the line, plug the point into the equation. So, when given an equation and a point, plug the point into the equation. If the point is on the line, I should say. So let's go ahead and let's do that here. 3, y lies on this equation, lies on this curve. So I'm going to plug in 3 for x. So I get 3 squared over 25 plus, now the y is just y, so I'm going to leave it as y squared. If this was 3, m, I'd make this m squared. Whatever it is, just plug it in automatically. Equals 1. All right, so now we've got 9 over 25 plus y squared over 9 equals 1. There's a couple of things you can do here. The easiest thing to do is just to subtract the 9 over 25 from both sides. And I'm just going to move over to here to finish this up. I get y squared over 9 and 1 minus 9 over 25. You do that on your calculator. That's going to give you 16 over 25. Now we're going to cross multiply, and I get 25y squared equals 144. Divide by 25, get y squared equals 5.76. And when we take the square root of both of those, we get y equals 2.4. Let's go up to 4C now. How many times will the line y equals 8 intersect the ellipse with the following equation? Identify and label any points of intersection. So we're just going to do a sketch here. My center is at 0, 1. We're going to count 2 units east and west here because underneath the x squared is a 4. So do that and that. And let's just label those. So minus 2, 1, and 2, comma 1. And then 7 units up and down because I have a 49 underneath here, and the square root of 49 is 7. So 1, 2, 3, 4, 5, 6, 7. So there's that point there. So that's 1, 2, 3, 4, 5, 6, 7, 8. So there's 0, comma 8. And we'll take another 7 down in the other direction. And our 7 units down in the other direction. 1, 2, 3, 4, 5, 6, 7. And that's going to be 0, minus 6. And there's my ellipse. And then the line y equals 8, make it a dashed line there. Y equals 8 crosses at y equals 8, just like that. A little tight in there, but you can see what I'm doing. And you can see that the answer to the question, how many times will they intersect? 1 time. And that's going to be at the point 0, comma 8. Lastly, we're going to sketch 4x squared plus y squared equals 16. Now, this was a little bit of a trick question perhaps at this point. How do we handle this? The key is you want a 1 by itself. So we're going to divide by 16, and we get x squared over 4 plus y squared over 16 equals 1. Well, this is pretty easy. I'm going to do this quickly here. The center is at 0, 0. 2 units to the left and right. 1, 2, 3, 4. 1, 2, 3, 4 units up and down. And there's our sketched ellipse. But this process here is handy. Whatever number is by itself on the other side, you divide by that number, that'll give you the 1 that you're looking for. This is the stuff that you absolutely want to know if you want to maximize your score on this exam. All of these things that we've talked about here will come up pretty regularly on the ACT. We get a couple more topics that we want to talk about here that come up much less frequently. If you want to be complete in your knowledge, continue on. Let's go to page 4. How to identify your conic section. That term conic section refers to circles, ellipses, hyperbolas, those types of shapes. We don't even know what a hyperbola is yet. We will in a moment. If you have an x squared plus y squared situation, then you know you're going to have a circle or an ellipse. If the coefficients are the same, then it's a circle. So for example, 3x squared plus 3y squared equals 9. If the coefficients are different, then you're going to have an ellipse. 3x squared plus 5y squared equals 9. If you have an x squared minus y squared or y squared minus x squared situation, then you're going to have a hyperbola. 3x squared minus 5y squared equals 9. Let's have you take a look at 5a, 5b, 5c, 5d, and just quickly write in a little identification. What conic section will be represented in each of these equations? Go ahead and pause the video. You have an x squared plus y squared, but the coefficients, the numbers in front of the x squared and y squared are different. So that's going to be an ellipse. In 5b, you're subtracting them. Nothing matters except that you're just going to know it's a hyperbola. In 5c, x squared plus y squared with the same coefficient. There's a 9 in front of both of them. The 1 doesn't matter at this juncture. The 1's only important when you're trying to graph it. Since the coefficients are the same, it's a circle. And then in 5D, it's a subtraction. So again, we have a hyperbola. Let's go to number 6 then, graphing hyperbolas. What does a graphed hyperbola look like? 6a, basic shapes. Here's the generic form of a hyperbola equation. You can translate it using the same rules as we did before. The a squared and the b squared in the denominators just represent whatever numbers you want to put there. If you have the x squared first and then you're subtracting the y squared, the generic shape is going to be like that. It's two open curves facing away from each other, and those curves go on infinitely. If the y squared's on top, then it's going to look like that. How do you graph a hyperbola? Not likely to really need this. Can think of one question that we saw that had this. But again, for completeness sake, just the very, very basics here, just what you need for the ACT. Our center's at 0, 0. Now what we're going to do is we're going to just simply take the number that's underneath the first term. Whatever the first term is, that's all we're going to worry about. The first term is a 9 in the first denominator. And as before, we take the square root of that. That gives us 3. And we count 3 units out in the x direction. For our purposes for the ACT, that's all we're going to worry about right now. That tells you where the, let's call them the points are on the curves that are closest to the center of the hyperbola. And again, it's understood that these are going to continue outward and infinitely. Why don't you try this now with 6c, do the problem there. You'll notice in this case, though, that the y squared comes first. Go ahead and pause the video. Our center's at 0, 0. Underneath the y squared is a 16. The square root of 16 is 4. So I'm going to count up 4 and down 4. And because the y squared is first, our curves are going to go upwards and downwards, or face upwards and downwards openly. And there's our shape. You go to page 5. There's one more thing we want to look at here. Something called foci, which is the plural of the word focus. The foci are complicated in terms of what they represent. It has to do with the technical definition of an ellipse or of a hyperbola, and we're not going to get into that. For our purposes for the ACT, let's just know their general location. There are 2 foci in every ellipse and hyperbola. They are located in such a way as to be symmetrical with respect to the figure. We just want to have a rough idea of where to find them. In an ellipse, you would find your 2 foci towards the opposite long ends. Again, they're going to be symmetrical with respect to each other and with respect to the figure. In a hyperbola below, you would expect, again, to find them within the curves, kind of symmetrically placed. All right, that's it. That's everything you need to know for the ACT, for ellipses, hyperbolas, and circles. Well, not circles, but that's another lesson. Hope you enjoyed this and hope you learned a lot. If you want to maximize your score on the ACT math section, you should know everything in this packet that we just did. Keep the packet. 3-hole punch it, put it in a binder, study all of this math before you go in, and you will do great. Thanks for watching, and we'll see you in another video. This is Peter from peterstestprep.com. Hey everybody, it's Peter from peterstestprep.com. Today we're going to learn the best place to begin. Our review of conic sections, ellipses, hyperbolas, and circles is blah, 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 blah.